Hello class, this is the notes for the second set of our calculus review. We're going to be talking about factoring. Again, it's one of those things that we just use a lot when we talk about doing some calculus. Factoring is just a big old monster of a topic. There's all kinds of things that could go into it depending on what you're dealing with. So there's no hard and fast rules. There's just some things to try to look for, and it's mostly just patterns. So what you should always look for is when you have multiple terms like this thing. We have a trinomial here, 3 terms. Again, terms are separated by addition and subtraction. And so what you're going to look for is the greatest common factor in all of the terms. So we're going to break each of those terms up. We're going to look at our numbers. We're going to look at our variables. So for the numbers, we got 3, 24, and 9. Those are our 3 coefficients. The greatest common factor between those numbers is 3. And sorry, my pen is not doing so well, but that's a 3. Then we look at our variables. We have y cubed, y squared, and y to the first. The most we can take out of those 3 things is y. All right, so that's what we're factoring out. Again, that's a 3. That's what we're going to factor out. So I'm putting a parenthesis. Now we're talking about what's left over. Factoring basically just means, like, when we talk about factors, they're things multiplied together. So we're going to take this 3y and multiply it by something to get us back to the original amount. So again, what's left over? What are we multiplying the 3y by to get to 3y cubed? So y squared. Plus, next term, 3y times what gets us our 24y squared? So 3 times 8 is our 24. Y times y gets us our y squared. Plus, then we got our third term. We already factored out the y, so that's taken care of. 3 times 3. I know that's kind of hard to read. I'm working on a tablet that doesn't work the greatest. But 3y times the quantity, y squared plus 8y plus 3. Okay, that's factoring. Now, this amount in the parenthesis here, this another trinomial, it kind of looks like the quadratics that you were dealing with and factoring in Algebra 1 and Algebra 2. We could use the idea of FOIL. I like to say FOIL in reverse to factor that, but with a constant of 3, we're not going to get that middle term of 8. So I'm just going to tell you right now, it's called prime factors. There's no more factoring we can do with this stuff. This parenthesis doesn't break down anymore. All right, the next example. X squared plus 4x minus 5, or minus 5. This is what I was just talking about. It's a trinomial. It fits this pattern of 2 quantities multiplied together. And what it is going to be is a binomial, 2 terms, times a binomial, 2 terms. So it's kind of like that FOIL idea. All right, so I think of this as FOIL in reverse. First terms, FOIL. First outside, inside, last. So first term times first term always gives us the first term of our quantity. So to get x squared, it's x times x. Then we got to do our last times our last. That's always going to give us our last term. So 2 numbers that multiply to be negative 5. We don't have many options. It's 5 and 1. One of them is going to be positive. One of them is going to be negative. So the key thing is that outside and inside part of FOIL. When we do the outside, like if we're talking about foiling, when we do the outside and we do the inside, we always end up adding those as like terms most of the time. And so we got 5 and 1, positive or negative on either one of those, but we got to be able to add to get this inner term of positive 4x. So I'm going to go plus 5 and then minus 1. It doesn't matter if you put the minus 1 over here and the plus 5 over here. But when we do the outside and the inside, we got a 5x. The outside gets us a negative 1x. So 5x minus 1x, there's our 4x. And that's factored. Our last example here, again, one of those patterns. You're going to see this one quite often. So what you're looking for in this pattern is a thing called perfect squares. Quantity multiplied by itself. We do have 2 perfect squares. And the key thing with this is that we are subtracting those. It's called the difference of squares pattern. Okay, 25 is 5 times 5. It's a perfect square. 9m squared is, it's a perfect square, but it's kind of a, I don't know if disguise is the right word, but that's what it is. To get 9m squared, we're going to take 3m, and if you multiply 3m by itself, 3m times 3m, there's your 9m squared. Okay, that's our pattern. It's fitting that pattern. We recognized it. So this is called a difference of squares pattern. We're going to take that 3m and the root of our second term of 5. We're going to take those two terms. In one parenthesis, it's going to be plus, so 3m plus 5. In the other parenthesis, we're going to do those same terms with a minus. And that's the difference of squares pattern. Okay, here it is in general terms. Kind of just, this is how you usually see it. A squared minus b squared. There's our two different, or the difference, the subtraction of perfect squares. Difference of squares, it's always going to factor in this way. All right, that's just a quick rundown of some factoring. There's always a little bit more, but with some of the more complex factoring that we're going to do, we're always going to work it out together. So I hope this helps. I hope to see you soon. Take care. If you have any questions, please send me an email, and we'll start chatting. Be able to help you out. Bye.